Hey guys, recently I learned a method to make smooth face shadow for anime character. By using this method, we don't need to edit face normal to fix our anime character's face shadow. I will share this amazing tech with you in this video. We will use a grayscale image to calculate face shadow area. No need to edit face normal anymore, which can save us lots of time. I will use Cone's model in Genshin Impact. I attached the model website in the description. You will find a character's model at the bottom of the web page. Download their model by clicking their photo. After download, extract the file, then you can see the folder structure like this. Textures are put in the text folder. The PMX file is the character's model file. I will use Blender to import and edit it. Blender can't import PMX file directly. We need to install a plugin called MMD Tools. You can find its GitHub link in video description. Click Releases here, download the newest version. Go to your Blender install path. Mine is 2.83 here. Open Scripts, Add-ons. Extract the plugin files. Copy MMD Tools folder to Blender's Add-ons folder. In Blender, choose Edit, Preferences, Add-ons, search MMD, check the MMD tools. Now you can see MMD tab here, which means install success. Then clean the default objects in the scene. In MMD Tools tab, click Import. Choose the PMX file we just mentioned. After a while, the character model will be imported. Choose Material Preview mode. Click the model's mesh, only mesh, not bones. Click Material Properties here, you will see all the default materials of the character. Press Tab to enter edit mode. Double tap A to cancel all selected. Choose the first material, then click Select button. Every material has its vertex group. We don't need too much materials, so next step, we can merge some of them together. Open Shader Editor, we can check whether two materials are using same texture before merge them. Select the first material, check its vertices, its face. When you select other materials, make sure double tap A to deselect first, otherwise you will select multiple vertex groups. Here we can see the second material are also face part. Select its vertex group, then choose the first material, click Assign button. This step will assign the second material's vertices to the first material. After assign, the second material will not include any vertices. We can just delete it in object mode, then rename the first material to face. Then do the same actions to other materials. Select vertices, assign to other material. After that, delete no-use materials. In Unity, create a new project, install URP, choose Window, Package Manager. Select Unity registry here, then search Universal, click Install button. After installation, in project window, let's create some folders first. Then choose Create, Rendering, Universal Render Pipeline, Pipeline Asset to create pipeline asset. Modify the default settings of URP. Back to Blender, let's export the model as a FBX file to Unity. In Unity, check the Models Inspector window. Currently, the model is too large in Unity. Let me put it into the scene, then create a cube to have a look. We need to change the scale of the model to make its size normal. Here we change the model scale factor to 0.1, then click Apply button. Now the model size can be accepted. We will create materials for the character. Then import model textures and the text folder we just mentioned. Choose Edit, Project Settings, Scriptable Render Pipeline Settings, select the pipeline asset we created before. Change this materials shader to URP and light, and choose their relative texture. Next, let's change the game camera's position and rotation. create post-processing effects for our scene. Add bloom and depth of field effects. Go to main camera component, check post-processing, and choose Anti-Aliasing to 8. Set camera background type to solid color. Choose a color for it. Go to game window to have a look. Modify the post-processing effects again under game window. This is my final settings. Import the face shadow texture. I attach it download link of the texture in video description. Set its compression to 9. We need to make sure the face UV layout suits with the face shadow texture. The face shadow texture is generated by shadow textures in some specific light angles. Use signed distance field to get the final map. I will introduce how to customize the shadow map in future videos. Next is the shader part. This is character's height. Let's define height forward direction and height right direction. The yellow arrow is light direction. Light direction is from world origin to light source position, which means the light direction in shader is opposite with the real light ray in game. Next, we need to use height right direction and light direction to calculate an angle value. The angle is not the angle between height right and light direction. When the angle between height right and light direction is from 0 to half pi, the angle value is from 1 to 0. When the angle between height right and light direction is half pi to pi, the angle value is from 0 to 1. When the light direction is on the right side of the head, the shadow map is from white to black along head's right side to left side. We know that the R channel of the white part value is 1 and the black part is 0. We will use R channel of the shadow map compared with the angle value we just mentioned. The face area will be lightened up if the R channel of the shadow map larger than the angle, otherwise it will be shadow area. On the right side, the angle is from 1 to 0. For example, when the angle is 0.9, only the nose right side area's R channel larger than 0.9. With the angle between head right and light direction increase, the angle decrease to 0.8. More face areas R channel larger than 0.8, so you can see the light up area increase. The light up area increasing with the light rotating. When the light direction is on the left side of the head forward, we will change the shadow map's direction that its left part is white and right part is black. On the left side, the angle is from 0 to 1. At the beginning, when the light rotates from half pi, most part of the face shadow map value larger than the angle value. The shadow part will increase with the angle value increase. About how to calculate the angle value, we will use height right direction dot product with left direction to get r.l. We will normalize the two vectors, so the dot product value will be the cosine value of the angle between the two vectors. Then calculate arc cosine r.l to get the angle range from 0 to pi. Let the angle divide pi, then multiply 2. After that is from 0 to 2, with the light rotate from 0 to pi. When r.l greater than 0, which means light on the right side of the height, the angle is from 0 to 1. Let 1 minus the angle, its range will become from 1 to 0. When r.l less than 0, which means light on the left side of the head, the angle is from 1 to 2. Let the angle minus 1, its range will become from 0 to 1. Back to Unity, let's implement the shader. First, we need to import a HLSL file named CustomLighting. There has a main light function in this file to acquire light info. This function has an input parameter world position, 3 output parameters, a float 3 direction, a float 3 color, and a float shadow attenuation. Well, let's use shader graph to make the face shader. Create shader universal random pipeline, unlit shader graph, name it to twin face. Add 2 texture 2D properties, name them to main text and shadow map. Add a color property, name it to shadow color. Add 2 vector 3 properties, head forward and head right. These 2 properties value will be passed by script, because the character's head's rotation may not same with the body, so we need to attach a script on the character's head to pass head direction to the shader. These 2 properties no need to be exposed. I defined their reference to underscore head forward and underscore head right. Set head forward default value to 001 and head right default value to 100. Okay, first let's sample the main text and connect to base color to debug. Set its default texture to face texture. Go to Materials, change Face Materials shader to twin face we just created. Back to shader graph, sample the shadow map. Here we need to sample shadow map twice. One is from left to right, the other is from right to left. Add a UV node here, split its channels. Let 1 minus its U channel, then combine it with V channel as new UV. Use new UV to sample the shadow map again. Connect the right side shadow map to base color. Don't forget to set the shadow map properties. Give it the shadow texture. Have a look at another shadow map. Now we have two shadow maps. Next, we need to use vector dot product to determine light is on the head's right or left side. Drag head right and head forward down. Create a custom function node. We will use it to acquire light info. Drag custom lighting file to source. Change the name to main light. Add a vector 3 input parameter. Name it to world position. Add two vector 3 output parameters. Name them to direction and color. Add a float output parameter. Name it to shadow attenuation. Add a position node, choose absolute world position. Connect it to world position input. Then we will split these three vectors channels, get their x, z components, then normalize the vectors. Calculate the dot product between head forward and light direction. Calculate the dot product between head right and light direction. Use R.L to determine the light direction is on the right side or left side of the head forward. Use compare node to determine whether it's greater than 0. Now we get the is right check result. We use a branch node to choose the shadow map. Due to we only need R channel of the shadow map, we only need to connect R channels to the branch node. Okay, let's debug it. I will rotate the light along y-axis from 90 degree to 270 degree. When the angle passes through 180 degree, the shadow map change from one to another. Next, we need to use R.L to calculate the angle as we mentioned before. Calculate R cosine R.L, then divide pi and multiply 2. Get 1 minus angle and angle minus 1. Use the same branch node to determine which value to use. Now we have R channel of shadow map and angle value. Next step is compare them. Use step node to do that. Shadow map connects the in port. Angle connects the edge port, which means if shadow map's R channel greater than angle, return 1, else return 0. Debug the step result. We almost get the final result. The white part is light up area, the black part is shadow area. Another factor of the face shadow is the angle between head forward and light direction. If the angle greater than 90 degrees, the light is at the back of the head, which cannot light up any area on the face. We will use head forward dot light direction to check it. Use step node. If the dot result greater than 0, return 1, else return 0. Then use the check result multiply with current shadow result. Now when I rotate the light more than 270 or lower 90, you can see the face are all black. At last, use the shadow result to learn between main text color and main text color multiply with shadow color. Notice to reverse the shadow result before connect it to URP node. Check the result. Give a shadow color. Looks great. At last, create a head towards class to pass head forward and head right direction to our shader. This class is very simple. Define a class derived from mono behavior and execute always attribute to make sure the script runs in both editor and play mode. This function uses two pass directions. First, check whether face material is null or not. Then pass these objects transform forward as head forward and transform right as head right. Execute this function in update method. Expand cone's armature, find head here, attach the script on it, then give it the face material. Now rotate height to check the result. That's all. Hope this video could give you a little bit help. Thanks for watching.